Okay, so for question 2, I see these different tape diagrams and they all have different unit fractions. So it looks like my first one I have thirds, my second one I have sixths, and then I have ninths, and then the last one is blank. So let's read the directions. Using the fractional unit shown, identify the fraction of the rectangle that is shaded. And then you're going to continue the pattern by drawing the next area model in the sequence and identifying the fraction that's shaded. Okay, so that first one, like I said, looks like we have thirds represented because I have 3 parts in my whole. That's my denominator. How many parts are in my whole? My numerator is how many parts are shaded or represented. So I can see that 2 of those are shaded. So I'd write that by that tape diagram. The next one, it looks like I have 6 pieces, and I can count 4 of them are shaded. And then that last one before the blank one, it has 3, 6, 9 pieces, and 6 of them are shaded. So I'm thinking just by looking at it, and they all seem kind of equivalent, that I'm going to see if they're equivalent to 2/3. So let's see if we can get the first one to be equivalent to 2/3. So 2/3 equals 4/6. Let's see if I can change 2/3 to be an equivalent fraction of 4/6. Well, 2 is smaller than 4, so I know I'm going to be multiplying. I can only ever multiply or divide in this case to find equivalent fractions. So I know I'm going to be multiplying, and I ask myself 2 times what is going to give me this 4 over here? Well, I know 2 times 2 is 4, and if I multiply my numerator by 2, I also have to multiply my denominator, and 3 times 2 is 6. So yes, those are equivalent fractions. Let's check to see if 6/9 is an equivalent fraction for 2/3. So this time I'm just going to do it the opposite way. I'm going to use division. I want to see if it'll equal 2/3. 6 divided by what will give me 2? Well, 6 divided by 3 will give me 2, and if I divide my numerator by 3, I also have to go and divide my denominator by 3, and 9 divided by 3 does equal 3. So these are both equivalent fractions. It also looks like I can start to see a pattern here in the fact that I multiplied by 2 here, and then 3 here. So I think that next box is going to be by 4. So we start with 2/3. And I don't know what that equivalent fraction is yet, but I'm going to multiply by 4 because that's what would be next in my sequence. If I multiply my numerator by it, I also have to multiply my denominator. 2 times 4 equals 8, and then 3 times 4 equals 12. So now I'm going to represent that in a tape diagram because you guys have a nice big square. Actually, here we go. Okay. I need to have 12 pieces in my whole. So I'm going to start with thirds because that's what I'm trying to make it equivalent to is 2/3. And I'm just going to go ahead, in order to hold myself accountable, I'm going to shade in those 2/3 to start with. And now see if I can possibly get 12 pieces. So I have 3. We've done this in class before, but I know I can make 4 new boxes in order to get 12 totals. But let's just count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Awesome. And let's see if I do in fact have 12 shaded. 1, 2, 3, 4, 5, 6, 7, 8. 8 shaded, sorry, not 12. 12 is my total in my whole. So there I've represented and written down what my fraction is in the sequence. The second part of the question says, use multiplication to explain why the first two fractions are equivalent. Well, awesome. I did that to even figure out my first part of the question. But if you need a refresher on that, go back and look at this screen right here. And we'll practice with this. Since I did it in division, we'll go ahead and write that in multiplication as well. So I started with 2/3. And I somehow got to 6/9. We know from our division earlier that it's going to be 3, but let's just pretend we don't. We're going to ask ourselves, 2 times what is going to give me 6? Well, 2 times 3 will give me 6. If I multiply my numerator by 3, I also have to multiply my denominator by 3. And there you have it. You've proven with multiplication how the two fractions are equivalent. And if you're ever second guessing yourself, you can always draw one of those tape diagrams to double check yourself. So that was all of question 2. And now we're ready for question 3. So question 3 wants you to cross out the fraction that is not equivalent to the other 3. So we have 1/3, 5/15, 3/7, and 3/9. Well, right off the bat, I can tell which one is not going to be equivalent. I know that 3/7 cannot be equivalent. Ask yourself, how do I know that? We've talked about related fractions, related denominators. 3, 15, and 9 all have a factor of 3. 7 does not have a factor of 3. But the great thing is, the second part of the question says, show how you know. So if you didn't see that pattern, you could just walk through each one and test to see if it is equivalent or not. So we'll start with 1/3. And we're going to see if we can get 1/3 to equal 5/15. Let's start with the denominator this time. 3, what do I have to do to 3 to get 15? I need to multiply it by 5. If I multiply my denominator by 5, I also have to multiply my numerator by 5. And 1 times 5 is 5. So yes, this one is an equivalent fraction. Okay, let's see if I can get 3/7 to be an equivalent fraction. Okay, so 1 times what is going to give me 3? Well, 1 times 3 will give me 3. If I multiply my numerator by 3, I also have to multiply my denominator. So let's check. 3 times 3. 3 times 3 does not equal 7. It equals 9. So let's cross that one off, but let's also go ahead and finish checking to make sure that our last fraction is also equivalent. So 1/3. And I want to see if I can get 1/3 to equal 3/9. So what do I do to 3 to get 9? Well, I know I'm not dividing because it's not going to get smaller. It's getting bigger. So 3 times 3 gives me 9. If I multiply my denominator by 3, I also multiply my numerator. And 1 times 3 does equal 3. So yes, that one is also equivalent. So in this case, you should mark off the 3/7 because we know that that one is not equivalent to the rest.